The third video here on nomenclature is going to deal with polyatomic ions. Polyatomic ions are ions that are made up of more than one metal or nonmetal. Mainly we're going to deal with oxyanions, but we're going to have a few organic compounds I'll throw in at the end so that you can see how these work out for naming. First, let's talk about the only two polyatomic cations you are going to see. NH4 plus is the ammonium ion. It's what happens when ammonia gets one more hydrogen. The ammonium ion is going to be the only polyatomic ion I ever test you over. You can see the mercury 1, which is Hg subscript 2 superscript 2 plus below, but I really don't care for that one. You might see it in your book and you might have a practice problem on the homework, but here all I care about is you memorizing this polyatomic cation for ammonium, NH subscript 4 superscript 1. So NH4 plus. That's the polyatomic ion I need you to memorize as a cation. While the cation seems simple, polyatomic anions can be quite hair-raising. Most of them are going to be oxyanions, and they're going to be a nonmetal with other oxygens attached to it. We use two types of endings, an ATE ending, and that's going to indicate the greater number of oxygen atoms present, or an ITE ending, which is going to be the lower number of oxygen atoms present. For example, CO3 2- is carbonate. NO3 1- is nitrate, but NO2 1- is nitrite. If I ask you to get me a bottle of sodium nitrite and you bring me a bottle of NaNO2, we're going to have a problem because sodium nitrite is not going to have the same reactivity as the sodium nitrate I asked you to get. These are also going to become very important when we talk about acids in a little bit. But for right now, the table here, you need to memorize these polyatomic ions and their names. We can have polyatomic ions of the halogens. So oxyanions, the halogens, are special because we can actually have four versions. We can have one with 4 oxygens, one with 3 oxygens, one with 2 oxygens, and one with 1 oxygen. Unfortunately, when we get to this type of naming, we have to use some prefixes. So we'll use the PER or per prefix to indicate the greatest number of oxygen atoms, and we add that to the ATE ending. So ClO4- is perchlorate. Chlorate now is only going to have 3 oxygens. Chlorite, which we saw was the fewest number before, is going to have 2 oxygens on the halogen. But if we remove one more oxygen, we have the lowest number of oxygens, we have to use the prefix hypo. So hypochlorite is going to be ClO-. Okay, so this table here for the oxyanions of the halogens of chloride, bromide, and iodide. These are the ones that you have to memorize so that you know how to properly use the prefixes and suffixes for these polyatomic anions. Lastly, we have some polyatomic anions, but they don't follow any of the other naming that we've talked about. And these are mostly because they're organic compounds. You might see CN-, that's cyanide, or acetate, C2H3O2-. There's also oxalate, C2O4 2-, chromate, CrO4 2-, dichromate, Cr2O7 2-, hydroxide, OH-, and there shouldn't be any Ohio jokes going on right now. Permanganate, MnO4-, peroxide O2 2 minus, and thiosulfate S2O3 2 minus. These are all other polyatomic anions that we're going to see throughout the course, so it's good to look at these and remember them. The biggest one I need you to memorize is hydroxide, OH minus, because hydroxide is going to be very important when we start talking about bases. So for right now, you need to learn how to properly identify the polyatomic anions of the nonmetals, how we're going to use our ATE, ITE ending, or have to use the per or hypo prefix in order to signify which is which. This is very confusing at times, but if you start working on making the tables as I've shown you in this video, it will greatly help you understand how to properly name these compounds. So now that we've looked at ways of naming our polyatomic anions, let's put everything together about how we're going to determine the name from the formula. We're first going to start by determining what the metal is, or the cation, and place that first. Then we're going to determine what the polyatomic anion is and place that second. So for example here, we have Na2SO4. Na is going to be sodium. It's going to be sodium 1 plus. The polyatomic anion is going to be SO4 2 minus. If we look back at our table that we made, it's going to be sulfate. So we have a sulfate that's got 2 minus charge. There's a 1 plus charge on the sodium, so we have to have 2, thus the subscript of Na2 in our formula. But now when we put the two words together, we're going to take sodium, put that first, then take the polyatomic anion, the sulfate, put that second, so we get sodium sulfate out of our formula. And sodium sulfate is a good drying agent that you might have to use in the lab when you get to organic chemistry. So just remember that you're going to be seeing this molecule in the future, so it's always good to know its name. Now, like we've done for all the other naming processes we've gone through already, let's turn it around. Let's start from the name and get the formula. We're going to follow the same set of procedures here. So let's just jump right into this. Let's look at copper 2 carbonate. The first thing we want to do is find the metal. It's going to be copper 2 plus, so we're going to write the symbol as Cu2 plus. Remember, we're getting the 2 plus charge because it's a copper, so it's a transition metal and it has a Roman numeral. The carbonate, we're going to get the symbol CO3 2 minus from our table that we have. So now when we put the copper 2 plus with the carbonate CO3 2 minus together, we're going to bring our superscripts down as our subscripts, and we're going to remember bring those in at a cross angle. And now we're going to have Cu2 parenthesis CO32. Whenever you have a polyatomic anion or a polyatomic cation and you have more than one present, you have to put a parenthesis around it in order to indicate that you're multiplying that unit by 2. Otherwise, it would look really weird to see Cu2 CO32. That's a lot of oxygens present, more than what you would actually expect to see. So we always want to make sure that we're using parentheses to indicate that that unit is being multiplied. Well, there is one other drawback though. 2 divided by 2 is 1. There's 2 present on both the copper and the carbonate, so we can reduce to the whole number. So copper 2 carbonate is going to end up being a formula of CuCO3. Now that we've practiced that, and we've practiced converting our names to formulas, I'm going to have you pause on this last slide. Make sure you record these formulas so that you can convert their formula to their name. And bring that to class so we can discuss it. If you have any problems, make sure you write down the ones that you're having problems with, because that's what we're going to use class for, problem solving. So make sure you practice these before you come in, and bring this list with you if you have any problems. I'll see you in class.